Thanks, Michael. So in a nutshell, everything I'm going over today is all about automation. Agile advocates to automate everything. So I'm taking this notion quite literally so that we can deliver software to users at the click of a button in any environment. So if you've ever attempted to do this, that you know that it's easier said than done. But the benefits are enormous because you can significantly reduce risk, errors, costs, and get software out to users more quickly, more often. So I'll be going over 4 aspects today. They're the technical principles, patterns, the actual deliverables that you can get out of implementing some of these patterns, and then the overall outcomes or the benefits. So in the technical principles, I'm basing all these patterns off of something I call scorching, also automating everything you can possibly automate, sharing, and then making the process continuous. So what I mean by scorching is that so many software and systems engineering problems occur as a result of assuming. So by scorching or eliminating target environment assumptions, you're less likely to experience machine-specific software problems. So you're able to better troubleshoot when something does go wrong. And you've removed the numerous and variable problems that can occur. So effectively what this means is that the software can be built on any machine because you've eliminated things like environment variables, machine-specific configuration that isn't scripted, and those sorts of things. It also means, I'll say often, is you clean up before yourself when you're generating software. The next technical principle is to automate everything. And automate everything and possibly automate. So sometimes you'll find people saying, well, we're only going to do this once, or my IDE takes care of this. The bottom line is that if you can't take a clean machine, perform a checkout from your version control system, type a single command, and get working software, you've got a problem. And this is why I like to work backwards from the problem in the sense, is this working from a single command? And if not, what do I need to do to get there? So automation reduces the costs and risks associated with delivering software. The third technical principle is that of sharing. And effectively, this means that you employ the repository pattern, which is described by Berzik and Appleton in their book, Software Configuration Management Patterns. And that is that you check in everything in order so that you can type that single command and get working software. And I'm going to actually cover this in the next slide. The last technical principle is that making it continuous. And really, it means that so you can run it automatically. So once you're able to create working software with a single command, this part's pretty easy. Now, to make something continuous means that it can run headless, and that is without a human doing anything, such as a scheduled or a continuous integration type of process. One note I'll mention is that my personal experience is with many different languages and environments, but I would say a majority of my experience is on Java-based platforms, so I'll probably use that as my typical examples. Just be aware that the patterns I'll cover can operate in any environment. So, I'll try to point out different examples. So if I use, say, Java and Oracle, you might replace that with, say, C# and SQL Server. But I'll try to point those out as we go along and kind of make the maybe grand assumptions that we're talking about Java and .NET environments. But again, it works in any environment. So as I discuss the patterns, I'm going to present the problem and then the solution on the first slide. And then I'll follow it up with an example of implementing that solution, or one of the examples of implementing that solution. So you may have heard this before, but a pattern is a solution to a problem in a particular context. And that is, you don't look at a pattern as a best practice per se. Instead, in particular situations, this is one possible approach to solving the problem. In other words, because real-world situations are always dynamic and specific to the environment, client, things like that, there's never going to be just do this and all your problems go away. So as you apply some of the engineering patterns to your projects, you might want to know, well, what am I going to get out of this? Or is it so all my peers can look at me as an agile engineering guru? Or is it so I can go home on time instead of staying late and missing dinner every night? Or is it so my company is more efficient and saves money? Well, of course, there's a lot of leading questions there, so that I'll say yes to all of those, and probably many more. But let's get down to it. The collection of patterns I'll be going over today will help you get literally a single command, one-click deployment And after some time, you can get to the point where you'll be able to create production-ready software every day. So imagine if at a time, anyone on your team with the proper authorization can click a button and get software into production. So that's really what the kind of the key deliverables are. So finally, the end goals, the outcomes, the benefits of this are to ensure that that you can create cheap, easy, repeatable, and reproducible and fast deliveries by utilizing these Agile engineering patterns. So when I say cheap, I mean that you make the deployments and releases inexpensive to reproduce so that the inevitable failures aren't costly and can be run as often as necessary. So that means that if all you have to do is click a button or type a single command, then you don't think so much about, if it was usually a manual process where someone was copying files over and configuring things, then you're going to resist going through those types of activities. So if it's a cheap process, again, you click the button, then it's not a big deal if something does go wrong. The other part is making it easy. So if the software is easy to produce, anyone with a proper authorization can do it. And you don't need, as Eric Minnick actually over at Urban Code, they create Angel Pro. He actually blogged on something called the Bob the Builder anti-pattern before, meaning you have just that one guy, that one person in your organization that's the only person capable of creating the software. So once the infrastructure has been established, deployment should become that single command or the click of a button. The next part is that it's repeatable or reproducible. So a consistent process, a repeatable process, means that the same processes can be run from any machine or any target environment. And then the last part is fast, failing fast, but also choosing the processes that are likely to fail fast, so you run those first. And it also means that you remove human bottlenecks from the production delivery process. So it's both the failing fast and also removing the bottlenecks to make it so that you can deliver software quickly. So each of the patterns I'll cover will produce one or more of these outcomes, and I'll try to point out which one of the outcomes is relevant to the pattern I'll be discussing. So let's get started. So the first pattern, as I talked about before, is a repository pattern. I've done my best to put the patterns in the likely order of implementation, which is why I'm covering the repository pattern first. Because quite simply, if you haven't implemented the repository pattern, you won't get single command, one-click repeatable deployments. And it's pretty easy to determine if you've got a problem that can be solved by the repository pattern. And in fact, you can find quite a bit by performing this simple test. And that is, you go to a clean machine, and if you're developing on, say, the Java platform, you might install the JDK, Ant, a database, and your SEM client. And then just type a single command if you get any errors that, after checking out. If you get any errors, your problem could be that you haven't committed the necessary files to perform a successful build or deployment. So you want to check in files that are necessary to perform the build into the version control system. So the repository pattern is quite straightforward. Ensure all these files necessary to build and deploy working software are committed to the repository, which means source code, configuration files, data, scripts, and even certain tools, everything. So here's this is more of a pretty straightforward concept. So the example here is just a diagram of, you have your build and deployment scripts, and then you have your third-party libraries, your configuration files, your tools, your DDL, your DML, your build scripts, your source code, everything that needs to be available in order to build and deploy the software actually gets checked into the repository. So you might be asking the question, what about large commercial tools, other tools that build and deployment processors rely upon? Do these need to be checked in? And so